Hello, good afternoon. Today I would like to lecture on chapter the title for design for environment in and manufacturing. So basically, this chapter has been emphasizing on the importance of production while maintaining consistency for good environmental situation. So bottom line is why is design for environment is important? Well, I think it is rather obvious that protecting environment is basically our importance as far as preventing our globe from being warming and depleting of resources, especially for minerals, and then avoiding the accumulation of such a vast solid waste. And we have to also consider not to pollute our water resources and our environment as far as particle is concerned from transportation. So we have to minimize it, and we have to avoid also for land degradation. So basically, all these major six activities contributing to environmental degradation is partly or mostly attributed from human activities or human industrial activities. So it is important because, well, if you remember in the past 3 or 4 months during this pandemic COVID-19, in control movement order, that most people are basically staying at home. So industrial activities are basically stopped. People need to stop their daily habits of discharging waste into river, into water resources. So this gives result to like in this picture, I'm taking it from I think Star newspaper online. So it shows that Malacca River is pristine with clear water and including its fish. And this is also very clear water at Malacca River. So not only up to Malacca in the Klang Valley, so Klang River also rather clean, and this is rather very nice, a pleasant view to see due to limited human activities as far as discharging waste to our water resources. So it is a proof that human waste, human activities, human dumping their unwanted material to water and land, causing environmental destruction. So the movement for design for environment actually initiated in the 70s by the proposition of Professor Papanek. He insists that uh, industrial designers need to be more or highly responsible for environment instead of merely paying attention for monetary profit. So he was the dean for CIT, California Institute of Arts, and also grading from MIT. So he has such a influential influential movement that propose for industrialists to be more responsible for protecting the environment. So in the new millennium, like year 2007, Bamra and Lockhouse, they also propose not only uh, protecting the environment, so the scientists propose environment plus social and also ethical implication of producing product that must consider for these additional three parameters: environment, social, and ethical. So by the United Nations Charter, the Brundtland Report 1987, they come up with a new initiative. They call it Sustainable Development, or known as SD. Sustainable development emphasize that development that comply to the needs of the present actual times and without endangering the ability of the future generation to meet their own needs. So while we are living now at the current era, so we must use the resources without sacrificing the needs for our future generation. So that is the basic uh, initiative created by the United Nations under Sustainable Development Initiative. Basically, if we care less on our environment during the manufacturing or during the industrial activities that we create among our factories, so the world has experienced severe global industrial crisis in many parts of the globe. For example, in Europe, Japan, and China. So let's take a look in each case. This is actually in Europe. They call it Meuse Valley, that is the area, and at Belgium. So this actually happened in 1930s. So in which in Belgium, during that time, perhaps due to weather in combination with the in the coal industry and due to the flow of the wind in that valley, it is reported that there was a very heavy smoke at that particular time. And such a heavy smoke contains sulfur dioxide and also sulfur trioxide, and also particulates, in which a particle from the fog, because fog is generated through coal uh, application. You use coal to burn for energy, and this coal also release very thick smoke like this. And on top of that, due to that time, the season is rather cold, so the fog tend to stay at the valley. It doesn't flow, and the wind was not that blowing during that time, so it is kind of a stagnant smoke, and that caused a severe health concern, resulting as far as many as 63 human deaths in even 1 week. So that is that was one of the worst case for environmental crisis in Europe, in particular in the Meuse Valley. In the other part of the world, like in Japan, this case was quite famous. It happened in 1957. They call it Minamata Disease due to chemical, I would say, pollution that goes into the water resources. So Minamata disease causes human development, like babies and teenagers, to be retarded. So actually, this is partly due to Japan industrial activities that was using mercury. So some of the industry are using mercury for their processing, and some of the leftover mercury are were being released to rivers, and ultimately the mercury go to the ocean and being sedimentized somewhere at the floor of the sea. And as a result, this methyl mercury uh, was eaten by a small, I would say, fish, or perhaps small kind of animal. And then this small animal being eaten by bigger fish, and that bigger fish actually later turn out to be in the food chain, and it goes to the market and being eaten by people in the locality, and resulting into this kind of retardation of people. And it is quite severe as far as it affecting the mind or the brain of the patient, and it caused them to be retarded. Another third incident for environmental crisis was in Japan. This happened somewhere in early 1913, 2013. So that was called Great Smoke of China. It happened in the eastern part of China, whereas this area is from Beijing, go south down to Shanghai, and some little part on the central China. So this was covered by heavy smoke, and the rest of the southern portion of mainland China also covered by light smoke. So this also caused very severe health concern and health impact on Chinese citizen. And this was due to, again, a coal industry for producing energy for the other energy to make production. So this was the third case of environmental crisis in the modern times. So as a result of this kind of environmental crisis, it contributes to the global warming to the whole world. So our Earth becoming warmer and warmer. So this partly due to the generation of carbon dioxide and methane and some other chemicals that is being released to the environment. So as far as this graph is concerned, we can see that back in 1950s and 70s, we are about 8.8 degrees Celsius as far as global temperature. So here was the 8.8, and as far as 2010 here, we are expected almost reaching 9.8. That is an increment of 1 degree Celsius for merely about 50 years time. So this was the graph on the overall in the olden days, and the graph is always increasing, except in the 50s and 60s. So this slightly flattened, but yet after 1960s and above until the modern days, new millennium, they are increasing. They are keep increasing. So this was attributed part of the existence of carbon dioxide in our atmosphere. So nowadays we have accumulated as many as 400 part per particle organic particles that are floating in the air. So this was contributing to the warmer environment to the whole world. So we have to pull it down as far as this level, which is 350 part per million particle in the air, so that the carbon dioxide in a more reasonable level, so that we have a slightly cooler environment in the world. So this will be the target, and this is the current situation at 400, and we have to reduce 50 part per million in order to slightly coolen the world temperature. So all these crises have we take a lesson learned. So we must change our behavior, our industrial practices, our manufacturing process, so that it is more environmentally friendly. So it was proposed for design for environment, as in 1970s Professor Papanek proposed to the whole world. So as far as design for environment, it is a method actually to minimize or eliminate the production process, so that it doesn't impact the human habitants. So product life cycle involve the production of the raw material, converting into a finished product, and then it goes to distribution for marketing, and the product is being used for 5 years, 10 years, and so on. So ultimately, it will be disposed, and this disposal requires that some of the material must be recycled, reused in the next production cycle. So this kind of movement is quite popular already in the developed world, like in Japan. So in specific, it is a Mitsubishi Motors. Most of Mitsubishi car, if they already end the life of its use, so some of their plastic parts, for example, their plastic bumper, so like this part, so actually Mitsubishi Corporation reprocess it, reuse it to be made for some other new product. For example, they were being made into plastic casing for the pen. So this was done under Uni Mitsubishi pen. So these are part of the effort to reuse the material that has already ended in terms of its original target design product. So as such, it is proposed for two life cycle. This is the first cycle, the first cycle that we have seen, production, distribution, use, and recovery. Some of the material they have to reuse, and some of the material which is organic, it is suggested it will be disposed in a proper way so that it can degrade into our soil, and it has a natural decay, and it serves as a new nutrients to the cycle of forest, for example, and it is later extracted and reused as another new material in the next cycle of production. So these are the proposed two life cycle of our resources. Several companies, I would say quite a number of companies have initiated this two life cycle. For example, Patagonia Clothing. So in 1990s, Patagonia has started recycling their old jacket or their old attire because they use a recyclable material like capilene fabric. So most of this fabric actually recyclable, so they can reuse it for the next batch of production in the second life cycle. Dunlop industry in the form of manufacturing boots, Dunlop Wellington. So they use recyclable material like polyurethane, PVC, and rubber. And this raw material actually recyclable. They can reuse it for the newly produced boots for Dunlop. Freitag bags. This is in the form like a canvas like material. This canvas they use for transportation to cover up their cargo and so on. So upon their cycle time being used, they recycle the material of this to make bags like this. So normally this is being used for the I would say in the form of bags, in the form of material that can people use to contain products or to contain material after their life cycle of using for coverage canvas has been expired. Stokke trip track chair. So they design a unique product in which the product is basically adjustable. So it is a simple chair, like kind of this Z design. So and it is adjustable manually. So you can adjust it up for babies as far as 10 years, 15 years, or even 25 years you can use, and you can adjust the chair seat for even teenagers and adult people. So this is a unique environmental concern design by Stokke. So how companies might proceed with implementing design for environment process? Well, basically DFE is strongly bounded with the top management support as far as process, as far as budget, as far as mechanism and implementation. So the company must set its DFE agenda. So they must set that kind of vision. For example, agenda by Herman Miller. It is an American furniture company, produce office furniture. So say they set, for example, the target zero hazardous waste generation, means no waste. All discarded product or all scrap basically reuse, either reuse in the second cycle, or they will be deposited organically into the environment. So once the top management set the agenda, so designers, engineers, and managers need to identify its potential impact on raw material or resources that they use for their production, their process, and also their finished good. So from there, normally the design engineer or the engineering department will select material that is recyclable. For example, PU is recyclable, polyurethane, polyvinyl chloride is recyclable, rubber is recyclable, PET, polyethylene Teflon, also recyclable. So these are those options that designer must choose for their production process to make finished product. And like PE, normally this must be avoided because polyurethane PE are non-recyclable, right? PE mostly used like for mineral water bottle. So those are some of the material that is not suitable to be recycled. So using this kind of material actually is slightly more expensive This one a lot cheaper. So there is a trade-off that designer, engineer, and producer must consider in order to protect the environment. So after that, so apply the DFE guideline to the design team or engineering design group, and so they must consider also on the process and how its implementation affect the environment. So compared to the goals like this zero waste generation or using green waste green energy only, so they have to compare with the actual goals. So if it's not meeting, then they have to redesign the material, the process, and if it meets the goal, then they can do some kind of measurement assessment on their achievement. So these are the proposed design for environment process as discussed in the books. Herman Miller. So I have highlighted this brand, American furniture company, a very established brand, about 100 years old company that are producing chairs in the form of environmentally friendly design and its material. From 1990s, they produced the Siri, Aeron, and then new millennium, they produce Mira, and nowadays they produce this Setu design, in which it is ergonomically designed, not only economics, so they are also of environmentally friendly category product. Herman Miller environmental goal for year 2020. So they said that the company or their manufacturing process must produce zero landfill. They must achieve zero waste material. They are not polluting the environment, zero emission, which is low volatile organic compound as far as particle released to the air, zero process water use, so 100% green energy use, 100% for DFE product for their sales, and they must meet the LEED certification, so which is the organization that highly applying energy and environmental design in their process and also in their product. So this is one example set by Herman Miller as what they call DFE agenda. So DFE agenda means that it is a commitment from top management so that they will protect the environment. Herman Miller case study was presented in or discussed also in the book. So they use environmentally friendly material that can be recycled. For example, aluminium. Aluminium is a good material that does not degrade quickly. So it is basically material that can withstand long time of usage. PE, polypropylene, so steel. So all these are material friendly to the environment, and they use approach for recycled material. Right? For example, 44% of the product weight are recyclable. They use assembly method which is easy to disassemble and also to be assembled back. And by target, the recyclable material that must be reused, they set 92%, which is quite high. But it is worthy of setting target so that the engineer, the manager can work out how to recycle 90% of his product weight into the second life cycle. And as far as if we notice that many of the waste of the finished product actually generated due to packaging. So the approach for manufacturer is that they have a lesser material for packaging. So they will use material which is qualified to be recycled. For example, carton boxes, they try to use lesser plastic for packing. They try to use lesser polystyrene for packing, even though they are cheap, but they are not recyclable. So the size and the weight of packaging also being minimized. For example, like you see if the IKEA product, their finished product actually packed in the kind of flat box like this, so that customer may use their own effort to assemble it to make a complete wholesome product. So as such, they will reduce the packaging. They will reduce also the weight in the size for shipping, so that they can have a more compact product in order to for distribution. Puma also make a smart move that they use lesser material for packaging. For example, 60% less cardboard than standard board. So if you buy like shoes, so we you could have this kind of packaging, simple kind of a box. It's not fully coverage, and this box serve as a kind of protector for the shoes, and later being inserted to the bag. So when you consume the shoes already, so basically this little cardboard material can be recycled, and that bag can be reused for many times for some other purposes. So this is kind of smart move in packaging of a finished product. So few simple rules in order to achieve design for environment. Actually, choose the material that can be recycled continually, right? So the material that is friendly to the earth, those organic materials should be prioritized, and avoid to use unnatural or chemical material. For example, plumbum, cobalt, halogen. These are quite toxic material to the environment. So many industry has banned this kind of chemical from their process. So that is one way. Another option is to use a cleaner source of energy instead of using coal or chemicals and fuel. So we have option to use cleaner energy, for example, like solar, wind, and also hydro. So on top of that, these are a few simple guidelines to protect the environment. So, in the summary, why we still using coal? Why we still use fuel or processes? Uh, Without doubt, these are in terms of average energy cost, they are lower. So when the energy cost is lower, they can industry can produce lower cost as a final product, right? However, the impact to the environment is also another costly if they are not avoiding this kind of source energy. So they must focus on the cleaner energy. For example, this is a more sustainable energy using solar, for example, wind turbine, using conventional hydropower and also geothermal power. However, due to this overhead cost of creating the infrastructure and installing the infrastructure, it contributes to the higher cost of energy. Higher cost of energy will translate into the higher cost for end product. So of course, customer would like to have a high quality product with lower cost. So this kind of situation is actually like a tug of war, in which DFE is always in a tug of war with DFM, the design for manufacturing, in which the subsequent chapter I will be discussing. So in manufacturing, profitability is basically derived from profit margin equal to how much price that you sell minus the production cost. So if the production cost through design for environment approach is already high, then you have a lower profit margin. In other words, DFE incurred higher costs. However, the target for design for manufacturing is actually to reduce costs. So at what part we could negotiate to have a balance between DFE protecting the environment and could produce product with a reasonable cost which is acceptable to the customer. So these are the main topic that we are discussing on protecting environment to produce a lower cost product. So here we are, design for manufacturing, the subsequent topic that we are discussing. Basically, manufacturer design for efficient manufacturing process, good material that protect the environment. So these are another focus of our subtopic. So in order to design for manufacturing at lower cost and high quality, of course, it is a team effort in which normally they are conflicting. Design engineering perhaps would like to have a very good design, but actually it is very costly to produce. So as such, companies need to come up with parameter to control their costs, and in order to produce the same quality product at the same time at a reduced cost. So this is the topic discussion is all about. In the textbook, it is discussed one automobile brand belong to General Motors in the form of Chevrolet Camaro. They were main production in 1990s, and Camaro uses a V-shaped engine. They call it V8 valve with eight valve, so with a V shape. So these are the case study product presented in the book. Well, even though this brand is not that famous in Malaysia, GM brands, actually few of the brands GM cars in Malaysia available, for example, Chevrolet, perhaps Opel and GMC. So from there, inside the engine compartment of this Chevrolet Camaro, they have this, they call it air intake manifold. This is for V-shaped engine. They call it V8, right? So this is the shape of construction of V8 engine in the form of slightly inclined at 45 degree for their carburetor for their valve. So there are four here and there are four here. That's why it makes of V and 8. So in this V-shaped V8 shaped engine, so they uses air intake manifold, or in other words, it is like a channel in which the air is being sucked from outside, filtered, and then will be channeled to carburetor so that it will get burned with the fuel. So this was the original design by using casted aluminum. It is, yes, aluminum is a recyclable material. However, it incur high cost. But they decide to design the air intake manifold into using a newer material, which is also recyclable in the form of thermoplastic composite. It has a lower cost, and they also improve the design with embedded another product so that they can plastic injected mold together. So these are the approach by Chevrolet Camaro by GM in order to reduce costs while maintaining the same performance. So it is a team effort in order to design from using aluminum to using thermoplastic. So there must be a close and good cooperation among manufacturing engineers as far as handling the process of producing it, and the production workers as far as handling the mold, the physical job that need to produce the finished product, and also the designers as far as designing a more efficient product and more efficient process, including material. The costing part must be carefully calculated. So all these are the whole teamwork effort for design for manufacturing. And a view of a DFM process. At the first, the engineers need to estimate the manufacturing cost, the overall manufacturing cost, and then, if possible, they must reduce the cost and the number of components that are required in order to assemble the whole product. And if possible, reduce the cost of assembly, and reduce also the auxiliary support to production, like from manufacturing group or from the logistic group, and later reassess the impact of the FM to and other supporting factors. First, we have to estimate the manufacturing cost. This is the uh, first step. We have to calculate the overall cost. In the manufacturing system, there are many components that come together, converting from this raw material before it becomes finished good. So inside the manufacturing system, they have the labor, they have the raw material parts, they have the assembly, and they need the equipment, they need the information, they need the schedule, and they need the toolings, they need the mold. So they need the energy in order to power up the process. They need the supplies from supplier, supporting services as far as maintenance, and the manufacturing also produce waste. Right, this is a part of the thing that DFE, the previous earlier topic that I discussed. So in manufacturing costs, this is the cost that incurred quite high high price, because manufacturing needs component, they need the process to assemble it, and they need the overhead, for example, like machinery support. So these are to estimate the manufacturing costs. So all these are component necessary, from raw material, processing and tool, including equipment and more. So then the next step is to reduce the cost of component. So if the components are a lot, so it will require a longer process assembly. So if you reduce the cost, so ultimately the cost of assembly become lower, and the number of handling become minimized. So designer need to understand the whole process, not only designing the product, but they must know how the product will be assembled, how the product will be tested, how the product will be packaged, delivered, transported, and so on. So as such, this process is quite, I would say, challenging for engineers to execute. However, they must reduce the cost of component. So basically, to redesign a component in the economy of scale, so manufacturers normally focus on mass production, which is they must produce with a big number of output quantity. So because manufacturer must control the variable costs, right, the fixed costs, and the total direct costs, right? For example, these plastic parts, perhaps this is plastic valve parts. In order to produce this part, they must have this mold, and this mold normally costs very expensive because it is made of solid metal, right? So when you calculate the variable cost plus with fixed costs and total direct costs, and say you have to produce 10,000 of this product, so per total unit cost, actually it just costs 13.66 ringgit or dollar, right? However, this is quite cheap. The mold itself is already cost 10,000, right? Because normally mold is very expensive, right? So if you project into a graph between total cost in against the number of units produced, right? So the cost itself here from here is already 10,000 for the mold. So in order to make sure that you make use of maximum value of the mold, so one, if you produce a 10,000 valve, right? So technically, each valve will cost for $1. So you must produce 10,000 valve for 10,000 US dollar cost of mold. So that is mass production, right? So in order, then you have to have a fixture cost, for example. So in terms of 10,000, 1,000, 2,000, 3,000, or 10,000, so this cost always increasing on top of the injection molding, on top of the material and processing, on top of machining. So you must produce at a big number quantity in order to reduce the cost per unit, so that you can achieve a lower cost per unit. So that is the basic of mass production concept. So next, the third step is to reduce the cost assembly. So this is the formula for DFA index, design for assembly index or ratio. Basically, you need to calculate the number of parts, right? How many parts for the final assembly product. For example, for cars, it is easily attain around 300 or 400 parts. And in order to assemble 300 or 400 parts, you have to multiply by 3 seconds and divided by the total estimated time of assembly. If you can bring the number of parts lower, right? Basically, the this number becomes smaller divided by this big number, so the FA index will become smaller. So in other perspective, you have to integrate several parts to become together, as far as the approach of integral design, and then you have to make easy for the assembly, like with approach of self-aligned parts, no error as far as insertion, insert from the top instead insert from the bottom. So because it is much easier to assemble product from the top, for example. So preferably the part could be assembled with one hand rather than two hands. So assembled by hand directly instead of using tools. So these are part of the takt time study that need to be studied by process engineer. So in order to reduce the cost of assembly, so reduce number of parts. So in this example for the case study for Chevrolet Camaro, for GM cars, so the parts for air intake manifold has been integrated, which is these are the part that actually belong to air intake, and later it is being integrated with the other new parts, which is this called throttle, right? So basically these are the throttle parts. So previously it was only this part, which is air intake manifold. Now air intake manifold with throttle. So you already reduce number of part by one by this approach. So now we see that this, I would say, among the second and last step, reduce the cost of production. So how to achieve it? We have to reduce the number of parts in production, the number, which is reducing. So as such, it is minimize the complexity. So as you have seen in the previous slide, the air intake manifold, they are being integrated together with throttle, that is already reducing one number of parts. So in this revision 1, they have 13 parts, whereas in the newer revision, by using newer material thermoplastic, they already reduced one, they have 12 parts. Basically, reduce the number of parts in production to reduce the assembly costs. Well, we could implement also a better process of assembly by having, I would say, foolproof method. For example, in this cassette assembly, this is the left reel lock, and this is the right reel lock. This is the supply, and this is the take up. So they use a different kind of lock on the top. For this part, they use for left, and the other design type they use for right. So this also to avoid the mistake in the process assembly, which is the right reel lock will go to the left, and vice versa. So this is also what we call prevent assembly error. So by color coding and by perhaps specific design shape for certain particular direction. So this is error proofing in process assembly. So in order to minimize the assembly process, we can have this approach. They call it pokayoke. It is a Japanese word. It means error proofing in assembly process, in which if you were to assemble two parts together, you can make it error proof, in which if the cylinder shape, so it must have the receptor of cylinder shape, so that the designer must design in such a way it is error free in later process, especially in the assembly. So in this kind of design, they better match with this design. This is for Pokayoke approach in order to avoid mistake in later process. Okay, class, that would cover this chapter 10 for design for environment and design for manufacturing. Thank you for your attention.